Yes, Prabhu.
Okay. So today's topic is soil science, because without knowing soil, you cannot do anything in terms of farming, right? So we have an institute here, Samavish Institute of Technology and Advanced Sciences, established by Harulas Maharaj. And I am the first professor for that. So you are hearing from me. Hopefully this will also grow over a period of time. People will learn, inspired by Swami Prabhupada, by my Guru Maharaj, Bhattrika Swami Maharaj, and the local Acharya, Harulas Maharaj. Okay. So we'll recognize soil as an important resource for serving Krishna by growing things uncontaminated by materialists. Describe basic soil properties from a Vaishnava farm perspective. Determine basic soil properties and limitations by observing a soil profile, and provide encouragements from Varnashrama projects. So it's very important to understand soil, because ultimately this is what is providing us food. You cannot eat computers, you cannot eat Tesla cars, you cannot eat anything, you cannot eat rubber tires. You still need to eat, right? So the science dealing with soil as a natural resource on surface of earth includes pedology. Pedology is a science of genesis, how soil came into being, how you classify soil and how you map it, the physical, chemical, and biological fertility and properties of these soils. So these are classic definition by a university professor in America. So soil fertility is like nutrient properties, because soil is basically rocks that have been pounded by millions of years of earthly processes, geologic processes, but then rocks don't have energy. So where is the energy coming from? It's coming from nutrients, which means biological matter within the soil. Then there is chemistry. You have chemical constituents, chemical properties, and chemical reactions. Then you have soil physics, like, if you put one type of sand on top of clay, how is it going to sink, versus if you put clay on top of sand, how will it sink? So these are all very important, right? Because once you start any activity on the soil, you need to understand how these interactions happen. Then you have soil microbiology, dealing with microorganisms, population, classification, and the role of transformations. Then how do you conserve soil? Erosion is a major thing. Like if you see the Ganges Delta, so much of erosion is happening and all the nutrients are going into Ganga, so that the coastal, along the coast of the Ganges River, uh, the fertility is going down. So unless somebody does something about it, there is a certain process by which your topsoil is lost, right? And same thing is happening with the Mississippi River in America, and more closer to the Seattle area, we have the Columbia River. And you should see, like the American Indians used to live exclusively on the Columbia River. They used to do transportation. It used to be like a highway, boats going every day with produce, with grapes, with raspberries, with cranberries, with blueberries, and they used to transport, a lot of minerals on the Columbia River. And now all that ecosystem has been broken because of fossil fuels, which means petroleum-driven trucks on the highways. So we destroyed one way of transportation and we created a new way of transportation. And then soil pedology, as I talked about, dealing with the genesis, how soils come into being. So typically everything starts with rocks, right? Igneous rocks means coming from lava, from volcanic. And in the Seattle area, we have many volcanic active volcanoes. So can anybody name one? What is the active volcano about 40, 50 miles from where we live? What is it called?
St. Helens?
Yeah, St. Helens, Mount St. Helens. It came about 200 years ago. It can come again anytime. And when last time when it came, there was ash all over the place. You may love your beautiful two-bedroom condo, but there'll be too much ash once that volcano happens, right? So those are called igneous rocks. Sedimentary. Sediment means layers of sediments, one over the other forming. Metamorphic means metamorphosis. If you remember your eighth grade physics, metamorphosis means change. So some things change due to cooling and heating and weather and rain and hail and so on. Like in Dallas, 1931, there was a hail. Each size of the hail was 6 inches long. If it falls on somebody's head, that's it. Skull will crack. That's how big the hail was. So nature is very powerful. We underestimate nature actually. So when such kind of hails come, your roof, you'll be left with a $60,000-$70,000 bill to just fix your roof, and your cars will be damaged, so many things, right? So all these natural processes will cause whatever you touch when you go outside the building and you touch anything on the ground, these have been caused by these things. So intrusive processes and extrusive process, very common thing like granite, you have your kitchen countertop granite that comes through an intrusive process, which means like layers of earth moving against each other. Then you have basalt. Basalt is very common on the earth, especially if you go to in Denver, Colorado, not Denver, Colorado, between Colorado and the neighboring state, Utah, you have various natural parks, Yellowstone National Park in the north, and then in the south, you have Grand Canyon National Park. You'll see a lot of basalt there. And then you have clastics. Clastics are basically broken down rocks. So sandstone is one of them. From that forms shale. And from chemical perspective, limestone is the most common thing. Like when Bhakti Charu Maharaj passed away, they put limestone so that his body doesn't degrade. Like if you see in Iraq, they are finding human skeletons 2 million, 3 million years old because they have been preserved in limestone. And also the Egyptian pyramids, they put limestone so that the body doesn't decay. So it's got a very good quality in there. Then metamorphic means changing roles. Foliated means with some kind of leafy matter. Non-foliated means no leafy matter. So if you look at slate, like when we were young, we used to write on slate, right? Palaka balapam, they used to say. So palaka means slate on which you write. In India, we used to write. At least I used to write back in small towns in Andhra Pradesh. So slate is caused by foliated matter. So it is stone plus some leafy matter. So they get compressed by the earth's pressure and it forms slate. And then non-foliated marble. For example, if you see in the Sammamish, ISKCON Seattle temple, you have marble on the first floor, second floor actually. First floor means ground floor. Second floor is the one level higher. So that marble comes from non-foliated, means there is no leafy matter. That's why it is strong, much stronger than slate and schist. Then you have sand. So here are components of soil, right? You have sand, which consists of quartz. You have feldspar, mica. Mica is a very, very brittle, but it's very shiny. You can peel off layer after layer in mica. So that is sand. And then you have silt. Silt, especially when it rains and the topsoil is washed away and it gets collected in some corners, that's called silt. And it's coated with clay. And it has got a physico-chemical properties of clay to a certain extent. So the human, not human, but the earthly realm is formed with sand and silt. So if you go to Ganges Delta, along the Ganges River, you'll see a lot of sand, right? These are finely ground rocks. And you also see silt, which forms between, like bigger than clay. Clay is very finely ground earth. And sand is coarsely ground earth. And silt is somewhere in between. So clay has particle sizes of 0.002 millimeter. It's very small. Millimeter is the smallest unit on your scale. You look at your kid's scale from school, ruler as they say, millimeter is the smallest unit. So this is 0.002 millimeter, means 2 divided by 1000 millimeter. That's how small clay particles are. And sometimes you have aluminosilicates, iron oxide silicates, iron oxide clays, and calcium carbonate clays. So there is clay made out of iron. There's clay made out of calcium carbonate and silicates. So it's very important. And clay is called the flesh of the soil. Means without clay, you cannot even have soil. Because in sand, you cannot grow anything. Can you believe? Like go to seashore and plant one tree or plant. It'll die very soon because there is no clay to bind it. Where will the roots go? Where will they eat from? Clay has all this, it captures all this organic matter. So soil is affected by texture, structure, organic matter, density, temperature, salt content. More salt content is there where? Near the ocean. Less content in the interior. If you look at the Godavari Delta in Andhra Pradesh, that's where most of the rice comes for South India. Just a small delta, that's it. Because it's very, very fertile. all the rice comes in South India from Godavari Delta, and all rice comes from North India from Punjab. Because in a small section there near the Sindhu River, you have very fertile soil, right? To large extent of Bihar, you don't grow any crops, no rice, no wheat. Roughly half of Uttar Pradesh, you don't grow anything. Most of the rice in North India comes from Punjab, right? Because that's where the gold is, the good quality clay and organic matter is, right? So salt content is actually a killer. You cannot grow any plants. Depth of the soil, and again, I'll show you some stratigraphy sections of how the soil layering happens. So to have good water retention, you need to have 2:1 ratio, two portions of clay and one portion of anything else. Otherwise, you cannot do retention of soil. Retention of water in soil. So here, I took this from one of the university websites. As I said, American universities are excellent in agricultural research. Only last 20 years, this nonsense called IT happened. Prior to that, America was the breadbasket of the world. They used to escape half of the world's wheat. Now everybody wants to sit on a chair and write Java and C++, right? The world has changed now in America. So you have water is unavailable from the plant if the soil particles are far apart. So it is called hygroscopic H2O. Then the second is capillary H2O. Capillary means if you take a straw, if you're drinking a cold drink, hopefully you don't drink Coca-Cola and Pepsi, you are drinking some juice, hopefully, for your health. By the way, Coke is acidic. Like recently I was looking at the acidic to basic alkaline substance. Coke is acidic, which means it will actually burn through your intestines and it will kill you very fast. If you want to die fast, drink lots of Coke. It will basically make holes in your intestines. It's acid. So coming back to this. So capillary action, when you drink a cold drink, you put a little straw in the drink and you suck it lightly like that. When you suck it, due to capillary action, the water comes up, right? So capillary action is necessary for water retention. And then there is gravitational. In gravitational aspect, the water is seeping down and forming groundwater. And without groundwater, Texas will not even be a state, it will be a desert. Texas is sitting on Aquagila aquifer. The aquifer supplies water to Texas and Oklahoma. And that's why we have very good crops coming from Texas. You call Texmati, right? The rice that is grown in Texas is called Texmati. In India, it's called Basmati. So Texmati is very good. Why? Because of that Aquagila aquifer. You can look it up on the internet. Oguallila, Oguilla aquifer. So that's where all the water comes from. And in Seattle, we don't need to worry about water because it rains a lot. So even if you dig like 6 feet, there is water underground. That is the good part. Bad part is because it rains so much, you cannot grow crops. They will all rot, right? Wheat requires water, but too much water, it will rot. So here is the pressure profile. Gravitational water is 1/3 atmospheres. Atmosphere means, anybody remember from their 9th class or 10th class physics class? So it is the amount of pressure that is applied on a unit area on the earth. There is some definition. So hygroscopic water has very high pressure, 31 atmospheres. And capillary water has 15 atmospheres and 1/3 atmosphere for gravitational water. So this is very important because gravitational water, because there's no pressure, what will happen? Tup, 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 it will just go down into the aquifer. It will not stay for your plants to drink. You need some amount of retention on the ground level for the first 6 inches or 8 inches for your plants to digest that water. So here is the formation of earth from various chemicals, right? So you have high in potassium and high in calcium, sodium, and ferritin, which is iron. So if you go to your doctor, especially women have low ferritin, they need to take iron capsules because ferritin doesn't hold very well for women, usually due to menstrual cycles and all that. So iron is very required for humans to survive on this planet. So these are various, if you subtract potassium, certain kinds of micas happen. If you subtract magnesium, you'll have vermiculite particle. If you subtract potassium from the high in magnesium type earth, then you have clay and chloride, like that. Anyway, this is deep science. You are not chemistry students, so let's skip this. So soil organic matter is affected by climate, natural vegetation, texture, drainage, cropping and tillage, and crop rotations. So Jaypal is a farmer. He has family farm. So crop rotation is very required. Why? If you don't do rotation, what will happen, Jaypal, if you don't do crop rotation?
Yeah, basically, so certain types of plants extract certain types of uh, minerals
Nutrients.
and
Nutrients.
uh,
Mhm.
nutrients from the soil. So if you keep on putting the same plants, then basically earth will run out of those minerals. But when you change it, let's say you put tomatoes one year and then you change to some other fruits or vegetables other year. Um, so the plants, it extracts some things from the soil, but it also give back something to the soil. So the tomato plant, it extracts certain types of minerals and nutrients, but it gives back something to the soil. So when you put next time some other plant, the other plant might extract the minerals which are given back by tomato plant, something like that.
Yeah, something like that. It is actually a fact. Like if you put groundnut, it will put more nutrient,
Yeah.
potassium. No, it will put N. What is N? Potassium is K. NPK.
Nitrogen,
Balance of, huh?
nitrogen,
Nitrogen. Yeah, excellent, excellent. Your memory is good. So everything is a fine balance of NPK, right? So N is nitrogen, P is, I believe, phosphorus, and K is potassium. So those
Okay.
three need to be in balance, otherwise your plants won't grow. So yeah, that's a good point. Without crop rotation, go and research on the internet. Dust Bowl in between 1910 and 1920, America put the same crop again and again in all of the North America, right? Northern part of United States, like Nebraska, Minnesota, and then going east. There are many states, right, all the way up to Chicago. So what happened? All the nutrients got finished, and the earth became like sand. It was no longer producing any benefit for growing plants. So they became what's known as a dust bowl. So then a lot of research went into it, and Americans said, yeah, we need to balance these NPK. And NPK actually comes a good balance from cow dung. Because back then they used to have American buffalo. Then they thought, hey, what is this buffalo business? Let's kill all the buffaloes and let's put artificial fertilizer. And then naturally the earth started dying out. Then they reintroduced the buffalo. Again, earth started growing. So earth is a living entity. So you have to put a lot of cow dung in order to, actually also earth is a carbon sink. If too much carbon dioxide is there, what happens? People's human beings' life will come to a threat. So when you put a thin layer of composted cow dung on the earth, it functions as a carbon sink, right? In thermodynamics, we learned source and sink. So just not sufficient to just take things from source, but you should also sink it. If you don't sink it, it will be a trouble later. So organic matter creates a granular condition of the soil, which maintains favorable condition of aeration and permeability. Water holding capacity of soil is increased and surface runoff, erosion are reduced as there is good infiltration. Runoff. This runoff, what happens is there is so much N being added through artificial fertilizer, nitrogen, and when rain comes from your farm, it will go into your nearby stream. From the stream, it goes to river. From river, it goes to in ocean. And if you look at in the east coast, Chesapeake Bay, and in the Gulf of Mexico, near Alabama and Mississippi, the water is turning orange because what's happening, a lot of algae is getting generated due to too much N in the water, and that kills good bacteria, and it kills all of the coral reefs. Coral reefs are living entities. They look like calcium, but they are not calcium. Their bodies are made of calcium, but they're actually one type of fish, ocean living entities. So all the coral reefs are dying right now. So America is in big time trouble. It enjoyed for about 150 years the benefits of nature, but now human beings are coming and killing all these natural elements. right? So runoff is a very important concept in earth science. My daughter took a course on earth science, and while I was helping with her homework, I learned all these concepts. She did a University of Washington course, and she got a good grade also, and I learned a lot as I was helping her with her homework. So real science is earth science because you need to eat. If you do computer science and when there's no food to eat and all of the coral reefs along the coast of America die, then what are you going to eat? Then you have to kill animals and eat first. And after that, then you have to kill humans and eat. That is going to happen. End of Kali Yuga, human beings will eat other human beings. But before that happens, we should exit. We should exit to spiritual world, not stay in this material world. So surface mulching, you see a lot of times you buy bags in Home Depot, like $4 or $5 bag of mulch, and then you put it on your backyard and front yard. So did you ever think why you put mulch?
No, I'm still confused about mulching.
Yeah, it lowers wind erosion because wind will take away layers of your earth on the top. So mulch lowers that, and it lowers soil temperature in summer and keeps soil warm in winter because we live in a cold climate in Seattle. So what happens is when you put mulch, it keeps the underground warm because there is a whole ecosystem under the surface. You have nematodes, you have, I'll come to that slide. You have so many different living entities under the ground. And if you don't keep it warm for them, they will be in trouble, right? So although it looks like, oh, I'm buying a $4 item from Home Depot and just covering my soil, there is a reason for that. There is a scientific reason for that. And organic matter serves as source of energy for microbes and reservoir of nutrients. So microbes and nutrients, there is a delicate balance. But if you put too much chemical fertilizers, microbes will start dying. And then you'll again have dust bowl. And dust bowl is possible even in Seattle area, although we are blessed with great water and great micronutrients. It's not guaranteed. Nothing is granted. So it will go away, right? And then fresh organic matter supplies food for earthworms, ants, and rodents. There's so many ants. I go walking every day in front of the temple. I live behind the temple. And then when I'm walking in front of the temple going through Highcroft, I see so many ants on the ground. And I'm wondering, where are these ants coming from? Literally thousands of ants live under the soil, right? So this organic matter, decaying leaves, provides food for them. And then organic acids resulting from decomposing organic matter help reduce the alkalinity. Otherwise, earth will become very alkaline, and then again you won't get crops, right? So there's a delicate balance of decomposing organic matter. Then there is a concept of humus. It's a highly decomposed organic matter, provides storehouse for exchangeable and available cations. So there are anions and cations in your chemistry. If you don't know what they are, look at your kids' chemistry textbook. So you need the balance of cations and anions. Then it acts as a buffering agent which checks rapid chemical changes. You know, there is a reason they teach us chemistry so that we can understand Earth, right? So we think, oh, chemistry is some boring subject. We have to pass it and, immediately destroy the textbook. No, there is a reason we need to learn chemistry so that you understand Mother Earth. So humus is complex and rather resistant mixture of black or brown, amorphous and colloidal organic substance. So even microbes are decomposing, right? Microbes are decomposing the matter, like the leafy vegetables, leaves, and they themselves are dying. So the combination is called humus. And it basically creates the acid-alkaline balance in the earth. Sometimes you'll put some things in your backyard and nothing seems to grow. So either acid is high or alkaline matter is high, base is high, right? So that delicate balance, that's why you need to crop rotation as well as take the mud from this corner of your backyard and put in the different corner. And then buy some additional humus from some place and then add it to your backyard just to keep the balance. And same thing with farm community. If you don't do that, then your acid alkaline balance will go for a toss. Same thing with your human body. You drink too much Coca-Cola for like 6 months, you'll fall sick. It happened to me, personal experience. Then I gave up Coke because then I realized it is actually poison. So one other concept, very important concept, is the carbon to nitrogen ratio, right? So who wants to read this? Let's give a chance to Adidev Das from Dallas. Can you read this, please? Okay, maybe he's too tired. It's already 11 p.m. for him. Okay, Shays, they read this.
Carbon nitrogen C is to N ratio. The ratio between the nitrogen content in the microbes and in the organic residues and to the carbon content is called a C is to N ratio. When when flesh plant residues are added to the soil, they are rich in carbon and poor in nitrogen. This results in wider C is to N ratio, 40 is to 1. Decomposition of the organic matter in the soil changes to humus, resulting in a narrow C is to N ratio, 10 is to 1. When materials like carbon are added to the soil, the microbial population increases due to the plentiful supply of food material. A lot of CO2 is released. During this process, the microorganisms utilize the soil for N for their body buildup, and there is a temporary block of N. When the decomposition of fresh organic residues reaches to the stage where the C is to N ratio is 20 to 1, there is increase in the availability of nitrogen.
Yeah. So it is a delicate balance of C and N going on. Carbon is required, and you can have that through a lot of cow dung, and it will capture the atmospheric carbon and it will put it in the ground. At the same time, if you have too much carbon, right, like 40 is to 1, then Mother Earth acts to decompose the organic matter to bring it back to 10 is to 1. 10 is to 1 is the ideal ratio, carbon to nitrogen, right? But during this decomposition, a lot of carbon dioxide is released. So which means you need to have a lot of plants and trees in that area to absorb that carbon dioxide. So that's why now there is a new thing. It is better to keep the plants alive than cut them for timber or for wood or for paper, right? Previously, people used to sell trees for paper. Now they're really realizing a tree is worth more alive than dead. If you cut off a tree and sell it for paper, you may get $500. But the tree may absorb $1,000 worth of carbon dioxide. So I was reading a paper yesterday or day before yesterday, where they're saying companies are giving money to forestry, people who grow these tall trees, so that not to cut them. They're paying money. Please don't cut, Baba. Keep the trees as they are. Because if you cut them, then we'll have too much carbon dioxide, and then we'll have other problems for our economy. So that is where the world has come to. So people are paying to keep carbon dioxide out. And only trees can absorb. You cannot absorb. If you absorb, you'll die. So in the cultivated soil, the C2N ratio should be 8 is to 1 to 15 is to 1. Right? That's a broad range. Ideally, it should be 10 is to 1 to 12 is to 1. So legumes, as Jayapal was saying, right? If you put groundnut, it will add some things into the ground, right? Straw is very bad. It has 100 is to 1, means it's too much carbon and too little nitrogen. Straw means after you harvest your rice, whatever is left is called straw. But the good thing is, if cows eat that, they'll give good milk. So what do? They wrap up the straw into big bales. And recently I saw Garuda Prabhu buying straw from some place in Kent or Inamclaw, and then he was taking it to Harulas Maharaj's farm to feed the cows. Right? So there is a delicate balance between straw, C is to N ratio, and cows. And then cows eat that straw and then give you cow dung, which will capture the carbon again into the ground. Very delicate balance, actually. So if the balance is broken, then you'll have what you're seeing right now in America, in the world. What's happening in North India? Temperatures are rising and cows are dying. And as a result, next year or in 2023 or 2024, they won't have enough cow dung on the ground. So crops will suffer. So the cycle is very delicate. We have to balance it. I mean, of course, I'm only talking about it, but people on the ground are doing all the hard work. Sawdust, when you cut a tree and you take the sawdust, too much carbon in it, 400:1. So in microorganisms, like the little bugs that are there in your backyard, they actually are lowering the carbon 4:1 to 9:1. So that's why these earthworms, these insects in your soil are very, very important. Without that, we'll be in trouble. So there exists a relationship between organic matter and the nitrogen content. Soil carbon has definite proportion of organic matter. So C/N ratio is very, very important. So C/N ratio is smaller in subsoil. Subsoil means below the top layer, topsoil and subsoil. There are two layers basically. Of course, there are many more layers. Okay, Jaypal, read this.
One minute. I'm attending from phone. The C/N ratio of soil is one of the characteristic equilibrium values. The figure for human being roughly 10:1. All the values from 5:1 to 15:1 generally found in more arable soils. The critical ratio 10:1 is a reflection of the dynamic equilibrium that results from the dominating presence of microbial population. The ratio being similar to the average chemical composition of microbial cells. As a rule, microbial protoplasm contains 5 to 15 parts of the carbon to 1 part of nitrogen, but 10:1 is a reasonable average for the predominant aerobic of fractions. Resistance to further decomposition can modify the C/N equilibrium values of humus. What is humus, Prabhu?
It's not humus, it's humus. Humus is decaying organic matter. So if you cut off a tree branch, then you take some leftover spinach stalks from your spinach curry, and then you put different kinds of things, right? As they're decaying, that's called humus.
They're good for the soil, right?
Yeah, very good. But why are they good? Because they are lowering the C value, right? So normally C value can range like 20 or 30 or worst case 40. But when you put humus, it lowers it down to 10:1. And vegetable plants and flower plants like it in that range.
This C/N ratio of soils can vary with the climate, that is rainfall, temperature, etc. C/N generally lower in warmer, arid soil conditions, regions than that of cooler ones. Humid soil conditions, in spite of having the same rainfall under both the soil conditions. The ratio is also narrower for soils as compared to the surface soil organisms. The carbon and nitrogen ratio in plant material is variable and ranges from 2:1 to 30:2. To legumes and farm yards.
Legume means a groundnut, peanut, those are called legumes.
So to legumes and farmyard manure to as high as 100:1. In certain straw residues, on the other hand, C/N ratio of the bodies of microorganisms is not only more constant but much narrower between 4:1 and 9:1. Bacterial tissue in general is somewhat richer in protein than fungi and consequently has a narrow C/N ratio.
Okay. So what did you understand from this, Disha Mataji? What is your conclusion?
What I understood from this is the carbon to nitrogen ratio is very critical for the soil, and if you want to grow anything on the soil. Well, it totally depends if you want to cultivate anything on the soil. Besides cultivation, it doesn't really matter for anything else.
Very good.
And so the most important thing is do you need the land cultivation to cultivate or not?
Yeah. And how do you regulate the C/N ratio?
uh, carbon to nitrogen ratio is regulated by uh, A, nitrogen substance, B, by ground cover or by legumes, or else um,
Yeah.
yeah, two of these
Right.
things.
Two examples are given here, primarily
Yep.
by organic matter called humus.
Yes.
That's a very
Yes.
important component. Legumes, you may not be able to grow everywhere. Like, for example, in Seattle, you cannot grow legumes, right? There is too
No.
much rain here. So that's just one technique in maybe in Hyderabad or in Punjab or someplace like that. Yeah. Okay, Disha Mataji, read this.
Sure. The C is to N ratio in soil organic matter is important for two major reasons. First, the keen competition of available nitrogen results when organic residues of high carbon to nitrogen ratio are added to soils. Because this carbon nitrogen ratio, that is 10:1, is relatively constant in soils, the maintenance of carbon and hence soil organic matter is dependent to no small degree on the level of soil nitrogen. So the carbon to nitrogen ratio obviously has practical implications on the availability of nitrogen in soils as well as in plants. As for example, large amount of fresh organic matters having wide carbon to nitrogen ratios 50:1 are incorporated into the soil under favorable soil conditions for decomposition. A rapid change will be found. The heteronophic microorganism, bacteria, fungi, and antinomycetes become active and increase their population with the production of large amounts of carbon dioxide.
Yeah, so even carbon dioxide production is good. Why? Because then you are getting bacteria and fungi. And bacteria and fungi also have a role, the good bacteria. Sometimes you have excess of the bad bacteria, and that's a problem. But bacteria is very important for the crops. Yeah, keep going.
Under these conditions, nitrate, nitrogen, NO3, or nitrogen, that's N, disappears from the soil because of the urgent need by the microorganisms. And for the time being, little or no nitrogen is available for plants. As the decomposition proceeds, the carbon to nitrogen ratio on the organic material decreases with the loss of carbon and conservation of nitrogen. As the decay process proceeds, both carbon and nitrogen are now subject to loss as carbon dioxide and nitrates, respectively. This is only a question of time until their percentage rate of disappearance from the soil becomes more or less the same, that is, the percentage of the total carbon being lost. At this point, the carbon to nitrogen ratio becomes more or less constant, 10:1, 12:1, always being somewhat greater than that of the ratio in microbial tissue.
Yeah, so there are two things happening here, right? One is there is high amount of carbon and certain chemical processes are set into motion. Then these bacteria and fungi, they will become active and they produce large amounts of carbon dioxide. And when that happens, as this decay continues, the equilibrium comes back to 10:1 to 12:1, which is the desired range for plants. So you see that bacteria and fungus are also helping in this regulation. You see that picture? So what happens when you introduce synthetic fertilizer which destroys this bacteria? What happens? And when the bacteria die, what happens? They are not converting this matter. And therefore, the ratio will be above whatever, around 20:1 or 30:1 or even 50:1. Therefore, your plants won't grow. So you are thinking that putting synthetic fertilizer is actually increasing your yield. But in reality, if you overdo it, it will actually kill the bacteria and it will reduce your yield. And this is what happened in parts of Tamil Nadu. Like during the British time, they were making, I don't remember the exact numbers, but 18 quintals a hectare or something. And now the yield came down to 10 quintals a hectare. So the more chemical they are putting, the less the yield is coming. Right? Okay. So yeah, we will do this page and then we'll stop. I know it's getting late for everyone. Yeah, continue, Disha.
Prabhu. Since carbon and nitrogen are reduced to almost a definite ratio, the amount of soil nitrogen largely determines the amount of organic carbon present when stabilization occurs. Thus, the greater the amount of nitrogen present in the original organic material, the greater will be the possibility of an accumulation of organically bound carbon. Since a definite ratio of 1:17 exists between the organic carbon and the organic humus, the amount of organic matter to be maintained in any soil is largely conditional on the amount of organic nitrogen present. The ratio between nitrogen and organic matter is thus constant. Organic matter, nitrogen, 20 is to 1 for most soils.
Yeah. So we saw the C/N ratio, carbon to nitrogen. Now is a newer ratio, organic matter to nitrogen. So for every unit of nitrogen to be captured in the earth, we need 20 units of organic matter. And where does the organic matter come from? From cow dung, from decaying straw, from previously used organic matter on the farm. So it should be recycled constantly. So whenever you cut the plants, right, on the farm, what do? They just leave it on the ground for some time for it to decay and then get absorbed into the ground. So this is very important. I mean, sometimes this knowledge is there through traditional, like father passes on to son and things like that. But where that knowledge is not passed, then we have to rely on scientific literature like this. Right?
So, Prabhu, then composting would be a good idea, right? Like
Composting is the only
composting.
idea, actually. It's not a good idea. Yeah, right now, everybody's taking composting and putting it on a pedestal. So you should not put things in trash. You should compost them. Like, have a compost pit or a bin and put everything in there. As it decays, it becomes very good fertilizer.
Got it.
Of course, I don't have much of a backyard. My backyard is like 3 feet wide on my back. So I don't have much space. But whoever has space, they should, have a big compost pit. Put everything in the pit, cover it up. Have 2 pits. Put everything in pit 1, cover it up when it's full. Then you leave it alone for 3 months. Put everything in pit 2, cover it up, and then dig pit 1. Use that as fertilizer, like that. Keep on going back and forth.
Got it. Okay,
Yeah.
Prabhu.
And surprisingly, human stool, the one that we discharge in the bathroom every morning, is very rich in lot of nutrients, but we are just draining it down. If you put that in compost pits like they are doing in parts of India, that becomes excellent fertilizer. Because what are you eating? You're not eating junk. You're eating nice cashews, almonds, right? You're eating good stuff. And even the stool has a lot of good nutrients, right? So that's something for people to consider on farms too, which they are doing in parts of India. But in America, for some reason, they think, oh, you should not touch it. It's bad stuff, so you should flush it down. And what do? And they flush it down. I was reading in my daughter's homework. All of our stool goes into one place in Seattle near the ocean, and they quietly discharge it into the ocean. So now all the fish are in big time trouble because they have too much of concentration of certain chemicals.
Wow.
Yeah, I mean, there is a process in nature, right? What we eat has to get digested and it becomes stool. I mean, then microbes will eat that and they create fertilizer.
That's right.
But if you put it in water and flush it, and then everything goes, it has to be going somewhere, right? So they quietly put it into Puget Sound. There is a place I saw in my daughter's homework. There's a photo of where it's all quietly discharged into the ocean. And then the fish, it is like a trouble, right, for them. They are used to eating some nice stuff. Now they're eating stool. So they are also very unhappy.
Yes.
Yeah.
Interesting.
Yeah. Actually, that's why, I mean, having done a full course with my daughter in University of Washington on earth sciences, Human beings are horrible people. We ruin the planet actually. All these other people are good. Other animals and plants are good. We are the bad people.
The
Okay.
last line,
Huh?
the last thing, soil biology.
Yeah. Yeah, keep reading.
By soil biology is the study of microbial and faunal activity and ecology in soil. The organisms include earthworms, nematodes, protozoa, zoos, fungi, and
Protozoa. Yeah,
bacteria.
fungi and bacteria.
Protozoa.
Yeah. I used to like biology very much as a kid, so I know all these terms by heart. Of course, I like so many things as a kid. So we are on slide 18. We'll continue next time, but I just wanted to show you a picture of the food web underground. Underground, there are all these living entities. Organic matter is eaten by bacteria. Bacteria is eaten by protozoa. Protozoa is eaten by nematodes. Nematodes are eaten by arthropods. Arthropods are eaten by birds or by animals. So there is this complete ecosystem under the ground.
Wow.
So if you break the cycle somewhere, like we are doing right now, then we won't survive. At least our great grandkids won't survive. You will just give them desserts. Not the desert like gulab jamun after dinner. Desert means real desert. Okay, we'll continue next week. Any questions before we close for the day? So we have to learn all these things. You know, Prabhupada, that's why I said you have to learn all these things because you are not independent of the world. We are dependent on this world.
Prabhuji, you briefly mentioned that in India, like, Punjab, Tamil Nadu, they are, or like parts of Andhra, they're good for rice and other parts are not. Is there a similar study in US?
Yeah.
What part is good, what is not? What plants grow well in
Florida
what?
produces all of your oranges.
Oranges, yeah.
And Western Washington produces all of the strawberries, blueberries, this berries and that berries. And Texas produces all the rice. And Nebraska and one of the two states produce all the wheat. The rest, everybody is eating from them. And California produces all your broccoli and cabbage and everything for the entire country. So if California and Texas came out of America, right? If they declared independence, we are toast.
Yeah.
So that's why my retirement plan is to go to either California or Texas. That's it. Because that's where all the food is getting produced.
Yeah, I think we should more farms in Texas then.
Yeah. That's why I sent you that article also, right? Around Texas. And actively looking for something in Texas myself personally.
Yeah.
I found a 10-acre farm for 140K. Can't beat that.
Nice.
140,000, nothing.
Where is it near the?
It's in Leonard, Texas, close to your farm in
Okay.
Wolf City. It's about 10 miles from Wolf City.
Oh, very nice. I mean,
I can
does this have
convince
a home or
Jaypal
is
to
it?
come and join my farm. Then we can grow good vegetables.
Definitely. Does this have a home or a
Yeah, it has
shelter?
a small home on that one. It's like a
Okay.
1930s home, but I don't
Yeah.
need a good home, right? I mean, I can live elsewhere. I just need a good farm.
Right. Right.
How much, Prabhuji? 150K for 10 acres?
10 acres, 140K.
Wow.
But isn't it very hot in Texas? What do you grow? It's so hot and humid.
Yeah, you need heat, Mataji. Even human beings need heat. We will die faster if we live in Seattle too long. I'm not joking. Here you don't get enough vitamin D. I took my daughter to doctor yesterday. She said give her vitamin D supplements. She's falling sick because there is not enough vitamin D, like that, right? So anyway, as you come closer to retirement, you should consider those things. Living on a farm, and that's the. I mean, not closer to retirement. Our retirement may be in 2 to 3 years, as American economy is collapsing, right? I think
Forced retirement. Forced retirement.
Yeah, forced retirement. What can you do? You see, we created cash, right? This is money supply. From 76 to 2008, like Sridhar Sham was saying, we created so much cash. We printed so much cash. And we printed so much cash from 2008 to now. Means just like Indira Gandhi created so much paper, printed so much money, what happened to India? Inflation rose too much, and people suffered for the next 20 years. Same thing is going to happen to America. How are you going to stop it? Right? Look at all these M1, M2, M3. These are different definitions of what wealth is. Right? Look at everything. Everything is going up, printing more cash, more cash, more cash. At some point, there'll be riots because there'll be less food and more cash. Just like in one South American country, to buy one bread was like 1 million local currency. One loaf of bread. Look at these graphs. Every graph, cash is increasing. You may think you are getting rich, but so is everybody else. And there is only so much food to go around. What will happen? One bag of rice will be $600. What will you do? Right? This is the differentiation between M1 and M2.
Walmart will become richer.
Huh?
Walmart will become richer.
No. The big corporations are getting richer. Have you seen that? In 4 months since the pandemic, Amazon stock doubled. Microsoft stock went up 50%. Only the rich are getting richer. You and I are staying where we are. Especially, I don't have any stocks. Due to philosophical reason, I don't buy stocks. It's considered gambling. So I'm getting poorer every day. You see this M1, M2 supply, how it is growing? Yeah. So I'll have a seminar on this one also, how money supply will make you poor in the future. And yeah, that's a different topic altogether. Okay. Thanks, everyone. See you all next week.
Hare Krishna, Prabhu.
Hare Krishna.
Chant Hare Krishna. So this is Krishna consciousness, because you may think I'll put chemical fertilizers and kill all the earthworms and all the insects in the ground. And 100 years later, our grandsons will all be dead because they don't have enough food to eat. So it's what goes around comes around. Yeah. So buy farms. Farms are very cheap, actually. Texas farms are very cheap. So buy farms with your money, because as M3, M2 supply grows, right, money will lose value. At least if you have a farm, there is something to go and stay. Yeah, and your bank will foreclose your home, for example. You still have a farm to live on, right? So the farm that I was looking, I don't know whether I'll buy it and whether they're willing to sell it to me. Has a small house on that one, 1930s house. But at least there is something, right? If the economy collapses. By the way, house prices are already coming down. In Texas, I saw 3 houses that I was seeing. They all made a $20,000 lowering prices. That's a lot of money. To earn $20,000, you have to earn $40,000 from your employer. And after taxes and this and that, you'll get 20K in your hand. Okay. Thank you.